Hello and welcome back to Mars Day 23. I hope you've had a great day so far. We've had some absolutely awesome afternoon sessions, and if you were there, I hope you enjoyed them. If you weren't, you missed out. But we have got lots coming this evening. We have got so much to get through, and we are going to be looking at some brilliant sessions, and we're sort of introducing you to our international stars and our guest planet on Mars Day, because Mars has kindly invited Jupiter in on their day as well. Now, we are going to start with our first session, and you lot are in for a treat, because what we are doing is we are going live to NASA, and we are looking at driving adventures and flying on Mars. And for this session, we have got the wonderful Keri, who is a systems engineer who is working on the next Martian helicopters, and we have Sophia Mitchell, who is a systems engineer and deputy lead rover driver of Curiosity. So hello, you two.
Hello, good morning.
Hello. Good morning, afternoon, evening. I am so looking forward to your session. I know you've got a treat in for us, and I know you have got such good information, because it's 2 years, isn't it, in February, that Curiosity and Perseverance and Ingenuity and Perseverance have been on Mars, and so I know you've got lots to share with us. And so I think without further ado, it is over to you two and all of your wealth of information.
All right. There we go. All right. So I'll start out here. So Sophia and I both work at NASA's Jet Propulsion Laboratory in Pasadena, California, a suburb of Los Angeles, and we are both Martians. So I have worked on the Mars Science Laboratory, which you all know as Curiosity. I originally started out actually as a science team member. My background's all in meteorology, and so I studied the Martian weather. And so I started out looking at the clouds and dust devils on Mars, and then later on became a rover planner, which is the fancy title for Mars rover driver and robotic arm operator, and also known as a porg herder. So I spend a lot of time training new Mars rover drivers as well. I'm also working on the Mars 2020 mission, which is Perseverance and Ingenuity. I am just starting training as a rover planner there, and I also worked as a helicopter integration engineer, which is the interface between the Ingenuity helicopter and the Perseverance rover to make sure that we're flying safely and we're going to get all the data back from the helicopter, and just kind of that coordination between the two. And I'm also working on the Mars sample return mission, which is the next mission we're going to send to Mars to retrieve the samples that Perseverance is picking up right now. And it has 2 helicopters a part of it that will help pick up the sample tubes to bring it back to Earth. And so I'm working on that as well. Now I'll turn it over to Sophia.
Hi, I'm Sophia Mitchell, and I have worked on the Mars Science Laboratory like Keri has on Curiosity rover. So I joined the rover as part of the drill feed anomaly team. So in 2016, there was an issue with the drill on Mars. And of course, we can't go fix it. We can't send someone to fix it. So we had to figure out what to do. I had a little bit of geology background. My background is in aerospace engineering and robotics. So that combination of skills is what got me on the team. I then worked on the SASPA team, which is responsible for arm safety, sample handling, things like that on that rover. And also as a rover planner, I'm now the deputy lead rover planner for MSL. So we're the people that drive the rover, we drill with the robotic arm, we use the instruments on the arm. We have a lot of fun together. So, and then I also work on the testbed team in the Mars yard. And on Mars 2020, I worked as the lead systems engineer for the gas dust removal tool. So you can see a little image there with the tool circled. That's the instrument that I worked on pre-launch. I BMV'd it. And then after landing, did the initial checkouts, and it was very fun. And then I also worked on SCS, later called S&C operations, doing some of the sampling for filling up those sample tubes that Perseverance is working on and dropping off. So yeah. So we'll go into a little bit about each of ourselves, and then we'll talk more about the missions, just to give people an idea of what you do to end up in these roles. And something to point out is that there's all sorts of different ways that you can end up being a rover driver or a NASA engineer. So these are just our stories, but there's many, many more. So I'm from Louisville, Kentucky, and I was not from a STEM family. A lot of people that I work with or talk to always either have or assume that you have to have parents that are engineers or scientists in order to get into science and engineering. And that's not true. My mom's an artist, my dad's a lawyer, my sister's a writer, and I work at NASA. So we're not really sure where I came from. I'm just kidding. But it's been a fun time, and they've all been very supportive. But I consider myself an explorer. So you can see I do all these different things outside of engineering with my life. I ride horses, I run, I go mountaineering, I travel. It's just because I'm a curious person and I like to learn about the world. And I think that is the kind of thing that they're looking for when they're looking for people to work at NASA. So next slide. Keri's got the slides. Thanks, Keri. So how did I get here? I've wanted to be an astronaut my entire life. So far, my work has gone to space. I still haven't, but that's pretty close. I got carried away with science fair. I did International Science Fair, if anybody's heard of it. And it's definitely a great experience with getting involved with research. And I continued doing research all through high school and through college. So you can see I'm at the Whipple Observatory down below, and some of my research that I presented in college down on the right. So that gave me the experience to be able to do science while also doing engineering, which is that combination that you would look for in space exploration, because we're not just building robots just for robots, and we can't do science without some instruments. So you have to combine the two. I also started flying airplanes when I was 10, because I know astronauts have to have pilot's license, and I have been determined. So that's me flying an airplane. But my background is in aerospace engineering. Like I said, I have a bachelor's and master's in that. And how I got to JPL is through the co-op program. I did an internship, several internships actually. And then when I graduated, I got hired at JPL. So moving on to Keri, I think.
Yeah. So a little bit about myself. I was born in Fairfax, Virginia, which is just outside of Washington, D.C. And my dad was a military contractor, so I moved around quite a bit between Texas and South Carolina and Virginia. So I generally say I'm from the South. I grew up always wanting to be a meteorologist. Being in the South, I got hit by tornadoes and hurricanes and all sorts of things. And so that was really fascinating to me. So that's what I wanted to be. I also am a huge Star Wars fan. I built my own R2-D2, which you can see in the picture there. And that's actually been a really fun engineering project. It was my first time really getting to look at diagrams and figure out, okay, this mechanical part has to fit here, but it has to be able to move. So how do I do this? And really learn a lot of hands-on engineering, which has really actually helped in my job, which is kind of fun that my hobby's helping real life as well.
You gotta tell him who's in that picture with you on the last slide.
Oh, oh gosh, yeah. So in the C-3PO costume is my boyfriend. He actually built the costume before we met. So we're both big Star Wars nerds. We met through our costume community, and then it turns out we both work at JPL. So if you want to talk about match made, there you go. And I'll also mention the BB-8 in the picture is actually one of Lucasfilm's BB-8s. They actually came to film at JPL one day, and so I got to help them around JPL. It was really fun. Definitely one of the best days of my life. So how did I get here? So I always grew up with that interest in meteorology, but I had no idea what I wanted to do with it, whether I wanted to be the person on TV or my dad was a military contractor in the Air Force needs meteorologists, so I thought about doing that. Being the storm chaser, there's just all sorts of things you can do in meteorology. And I had a little bit of an interest in space. I had a telescope, but my family was doing the whole Disney World vacation in Florida. It just so happened to be the week of a space shuttle launch. And so we went to go see the space shuttle launch, and I was like, oh, that's really cool. Maybe I'm interested in that. So I went to space camp. So you can see some of my space camp pictures there. And then I had to make this decision of what do I do for college now that I have this interest in space and weather. And then I found out at Texas A&M University, there was a professor there who studied the weather on Mars. And I was like, aha, there it is, the space and the weather together. And so that's what I ended up doing. And I got my bachelor's in meteorology along with minors in math and earth science, and then stayed for my master's degree as well, working with this professor. And through that experience, I got to work on a bunch of different Mars missions. So Spirit, Opportunity, Phoenix, and Curiosity as a science team member studying the weather on Mars. And so when I was done, JPL was like, hey, do you want to come keep doing that for us? And that's how I got it to JPL. So with that, I think we'll start talking a little bit about the missions.
All right, so I'll take Curiosity. So this is Mars Science Lab Curiosity. So this rover landed in Gale crater in 2012. And this was the first time that JPL used a sky crane, which is that crazy jetpack system, to land a car-sized robot on Mars. And I would have loved to have been in the room when that landing system was recommended by the engineers, because just to take you through it really quickly, we've done it twice now, and only twice, because you can only ever test it on Mars. It comes in, drops the heat shield after it slows down, has this supersonic parachute. It's the largest and just craziest parachute that's ever been made. Slows down to the point where then the rover can drop out of that back shell, and then a jetpack turns on. And it autonomously jetpacks itself close to the surface, about 20 meters off the surface, and then uses a sky crane maneuver to lower the rover while the jetpack's still going and hovering to the surface. And the wheels drop down about halfway down, and then the second those wheels make contact, then there's explosives on the back that cut the line between the rover and that jetpack. The jetpack flies off, and now we have a rover on Mars. And yeah, you can only test the parts of it. You can't test it all together. So the first time it worked was in 2012, and the second time it worked was in 2021. And we'll see if we use it again. Currently, Curiosity, which Keri and I have, like I said, both driven. Keri was actually the deputy rover planner just prior to me. We are currently driving through a rhythmically laminated unit of what's called the marker band. So we're driving up this crater called Gale Crater, and in the middle there's Mount Sharp. And if you think of when you go to a canyon, or if any of you have ever seen or learned about the Grand Canyon, there's those layers of rocks, and it's like a history book for geologists. So we're seeing that as we drive up this mountain, we're seeing these layers and seeing the history of what went on Mars. So what environment, right now we're trying to figure out what sort of environment made this interesting marker band feature. You can see these like undulating layer that we have here in front of us. And so that's literally a picture from this week on our operations. So right now that's what we're doing. And then on to the next slide. There we are. So talking a little bit more about Gale Crater, just quickly, we think it's most likely an impact crater that filled with liquid water shortly after impact. And so each of these rovers has been sent to a different part of Mars depending on what we're looking for. And so for Curiosity, it was kind of on the back of the previous mission, Spirit and Opportunity, which was known as MER, Mars Exploration Rovers. Those were looking for signs of water on Mars, and they believed they found them. So then this impact crater that was believed to have previously been filled with water became more interesting because it was more likely it was. And so if you think about, if you're wanting to learn about a planet, if you could dig a little trench and see what's in there, then that's where you'd want to go. So that's where they sent Curiosity, and the landing ellipse is this little blue spot, if you can zoom or squint in really close and see. So that's why we went there. It's got sulfates and clays that we've detected from orbit, which led scientists to think that there's probably water there for a while, and so we want to see what was going on in the Martian history. Since landing, Curiosity has found evidence that about 3.8 billion years ago, this environment could have been microbe friendly. We are quite literally a science laboratory. There's instruments in the rover that we put Mars rocks into to see what they're made of. And we're finding things that tell us it could have been microbe friendly, so that's very exciting. We found organic molecules, which just mean molecules that have carbon in them. Doesn't mean they're alive, it just means there's carbon. Which is another known building block of life, though, so it is exciting. We've also seen a methane cycle that we just don't understand. We've seen a similar thing happen on Earth, but we don't know why it's happening on Mars. And there's also evidence of mega floods about 4 billion years ago that just brought all sorts of sediment and all sorts of different things into and out of the crater. And that picture is also just some of those layers that I was talking about. But from our perspective too, driving on Mars is just a beautiful place to be. There's all different sorts of colors of rocks. We get to shoot things with a laser. That center picture at the top there, those little divots are actually from our laser shooting the sand and pushing the sand away as it evaporates parts of it. And we have clouds. We take little pictures and put them together in GIFs, and that's clouds moving across the Martian sky one day. So it's just an absolutely gorgeous place to be. Right now we're driving through, we drove through the center of this bottom photo, and then went up into the left of that canyon. And that's kind of part of our path up Mount Sharp. And a lot of these pictures are color balanced. Like the Martian sky is not quite that nice baby blue, but it looks very nice for a picture. So. And a question we get a lot too from our outreach photos, as you can see on the right here, is how do we take those selfies if nobody's there with the rover? So there's a reason why the robotic arm doesn't show up in those selfies, and it's because we're using it to take them. So the robotic arm you can see on the left, that's we took a picture with the mast camera, which is on the rover's head. Every time we took a picture with Molly, which is the camera on the end of the robotic arm we used for this. And that was just showing exactly how this photo was taken. So it's a series of 50 pictures, and we put them all together, and that's how we do that. All right, and then I will also chat about Percy, and then we'll go over to Keri for the last two. So the Mars 2020 rover is Perseverance, but we call it Percy for short. And 2020 is continuing that exploration of what was going on in Mars's history. So we had the MER rovers, which were looking for signs of water. We have Curiosity looking for building blocks of whatever was going on Mars, if there was something going on or not. We don't know. And then we decided to send the Mars 2020 rover to collect samples, do some science, but mostly collect samples into these sample tubes. So then we can bring those back to Earth and study them here on Earth, because we realized there's no amount of laboratory equipment that we could send to Mars to guess what we've been running into. And it's just better to have the rocks here and have all the world's best scientists just looking at them together. So it's sealing those rocks for return to Earth by Mars Sample Return, which is a NASA and European Space Agency collaboration that Keri will talk about. It landed in Jezero crater on February 18th, 2021, as most people probably remember. It was very exciting. It's our heaviest rover, so it is the same drivetrain as Curiosity, but it's a lot heavier. It has a lot different equipment in it. And what it's up to is it recently dropped its first sample tube at Three Forks Sample Depot. So that sample tube on the ground, if anybody has ever been geocaching, that's essentially what we're doing on Mars, is we drop these sample tubes off and we know the exact coordinates of where that happened. And then we name it. So this one's Three Forks Sample Depot, and then drive away and go collect some more samples and drop those tubes off. And this is the first and only known interplanetary sample caching depot in the universe. So that's what's going on Mars right now with Percy.
Yeah, so switching it over to a bit more about flying. So Perseverance also brought along Ingenuity, which was a technology demonstration just to prove, can we fly on Mars? And it was attached to Perseverance's belly, and we had to do this very long and complicated dismount, and it went perfectly, which was great, because then we got to fly. And we had originally only planned to work for about a month and fly about 5 times, testing. Our first flight was just straight up and down, and our second flight was up, turn a little bit, fly a little distance, come back and land. And it was just getting a little more complicated each time. And now we're 2 years into operating. It survived the Martian winter, which they did not expect. And we've completed 46 flights. So again, really awesome that Ingenuity is still going, and they're really testing all the capabilities just to see what it's like for continuing on, and how can we use helicopters in the future, and testing all these new features, which I'll talk a little bit about once we get to the Mars Sample Return mission. So Jezero crater is where Percy and Ingenuity have landed, and it's a double impact crater, so it filled with liquid and made it into a lake at some point. And you can kind of see this kind of big blob up on the left here is what is called a delta. And so if you've ever seen at like a river going into an ocean, it kind of makes this like little fan shape, and that's all the sediment in the river kind of depositing into the bottom. And so scientists are really interested in that because it will have a lot of interesting history about Mars in there. And so that's one of the main reasons they wanted to land in this crater. And so we're just now approaching that delta. You can see we kind of landed in the middle of the image at the Octavia Butler landing site. And we've now made our way over there, and Ingenuity is flying ahead of the rover, helping to scout which way the rover can safely drive up the delta, which is pretty exciting. So the scientists are like so excited. They're just really getting into the cool science now. And so this is just another collection of pretty pictures. And one of the things that is really cool about Perseverance is it really relies on auto navigation capability. We have that capability on Curiosity, but they've upgraded the computers and everything with Perseverance to make it a lot more efficient. So auto navigation means that we can kind of tell the rover drive off in this direction, and it will actually figure out how to safely drive there by itself. So that's a pretty fun capability that really has racked up the distance and driving for Perseverance. And we got some really cool videos as well of Ingenuity's first couple of flights. So we took a series of selfies there on the left to show that dismount and the drop off. And we actually have really nice color cameras on Perseverance. And for the first couple of flights, Perseverance stayed nearby just to watch Ingenuity so we could have those cool videos that you can see there. And Ingenuity also has cameras on itself. So we actually get videos of it flying. And one of the new capabilities they're testing is actually being able to identify what terrain is safe versus not safe, so it can figure out where to land itself, which is pretty cool. So that brings us to the Mars Sample Return mission, which is our next mission to Mars. And it's a joint effort between NASA and ESA. And so we want to bring home all of those rock samples that Perseverance is collecting. So there's going to be a big lander that has a robotic arm attached to it and a rocket inside of it. And so the plan is either Perseverance goes up and actually just hands the sample tubes to this lander, and the lander will put them inside the rocket, and the rocket will come back to Earth. But that's also many, many years from now. And so if something happened to Perseverance, we actually are bringing 2 helicopters with us that will have little robotic arms and wheels. So as a rover planner, this is really exciting that you get a 3-4, you get to fly, you get to drive and use the robotic arm. And so we'll actually use those helicopters to go collect these sample tubes and bring them back to the lander so they can get put in the rocket and sent back. So it's really exciting. So hopefully we'll get samples back in a couple of years. So essentially, Perseverance is collecting all these samples. We'll hand them off to the lander, and ESA is also building the orbiter that will capture that rocket and bring all of those sample tubes back to Earth. So this is really a good collaboration between NASA and ESA. Really excited to see the partnership there. And Sophia, I'll let you start out here.
Sure. That last picture is a very Rube Goldberg way of getting a sample from Mars to Earth, but it'll work. So just some lessons to pass forward, and then we'll go into our Q&A part. So some things that Keri and I have both learned from working and we'd like to pass forward especially as women, and I am mixed, so women of color. Just be assertive and persistent. There's a lot of paths to the same goal. Keri has a background in meteorology. I'm an aerospace engineer. We have a couple of people on our project that are they were born in Great Britain and moved to the US. I know somebody who works at JPL that has a degree in music on the French horn. So it's really more about how you apply those skills and how you apply your problem solving. There's a lot of paths to get to the same place.
And I'll add real quick that one of the folks who invented basically how to drive Mars rovers is a bachelor's in pottery and sculpture. So, it really doesn't matter the degree. You'll get here if you want to be here.
Yeah, and that goes into the next thing of setting goals and challenging yourself. You don't go from pottery to Mars rovers by just sitting. You have to figure out what you want to do and then go do it. And then also make sure you cultivate your passions outside of school and work. It's healthy, and I'm a backpacker, for example. So when I'm looking at where to drive the Mars rover, I'm actually thinking about backpacking And that's something that I've been able to bring. And then also when you're on a team, be open. Don't be afraid of making mistakes, because that's how you can build proficiency. And yes, we have things where we have to do it right the first time, but that means that we have to do a lot of practice times where we don't get it right to make sure we know how to do it. And that's how we're so successful. And if you're not failing, sometimes you're not challenging yourself enough, but also don't be afraid to ask for help if you're failing a lot. And then finally, diverse teams are important. You want to have a variety of perspectives, backgrounds, skill sets, personalities, life experiences. It's going to make the whole project stronger. So you can see on the right, we've got our International Women's Day photo from a few years ago from JPL, and JPL has since gotten a few more women than that, I think, in our photo. And I think they'll be releasing that new one tomorrow. And the photo above it is actually the Perseverance rover team just before launch. And there's 800 people in that picture, and that wasn't everybody involved. So that's how large those teams are. It's not just, me and Keri driving around on Mars. There's, on any given day, there's 5 of us working together to drive the rover. So it's a very teamwork-based job.
Mm-hmm.
And also have fun.
Yep.
The 2 left memes are real memes from the meme channel for the Curiosity rover. We have a good time together. So, and that's part of what makes the job so exciting. It's, at the end of the day, you're driving something on a different planet and exploring, and it just doesn't get any better than that. So that's it. And I think we're ready to go into questions then.
Brilliant. Thank you both so much. That was so informative, and not just about, your jobs, but about who you are and how you got to your jobs. And we have a fair few questions coming in. Now, if you at home want to ask some questions, just go to the Q&A section of the link and ask your questions. I'll put as many to Keri and Sophia as we can. But to give you time to put your questions in, I have got one of my own. Now, both of you have experience of driving the rovers and teaching others to drive a rover. Could you just sort of spell out, I suppose, bit by bit, how you do that? Like, obviously it's remote, but you sat at a computer. Is it a bit VR so you can see what's going on? What do you actually do when you're driving the rover? Is it by yourself, or is someone in control of, let's say, the wheels, the other person's in control of the arms? How does it happen?
You want to answer, Sophia?
Sure, I can answer that. Okay. So I can answer how we drive, and Keri can talk about training, since she actually revamped the whole training program. So when we drive, it's kind of a misconception that we're joystick driving like a video game. It's really that we have sequencing. So the rover has its own computer language, and we have that back on Earth. So we have sequencing, and then we have a high fidelity, a very highly accurate model of what the rover looks like and what the ground is like on Mars. So one cool thing about our cameras is that we get data for every pixel of how far away that pixel is from the camera. So we can put together these meshes in 3D of what's around the rover. So if you look at our screens while we're planning, then we have these big 3D meshes in the Mars rover. It looks like a little video game. And that's where we plan what we're going to do for the day. And then we have a system that can replay what those commands are doing to make sure that everything is good. It's a big team each day that we plan. We'll plan usually 1 to 2 days, but sometimes 3 up to 10 maybe on a holiday, days at a time. And so like I said before, we'll have 3 to 5 rover planners. We'll have a bunch of different seats that are associated with getting the data back down onto Earth and making sure everything is how we think it is before we send new data up. All the people involved in getting the data together to send up, and of course all the science teams, because we use the instruments, but we don't know we're not the scientists that, control them. Like, we know what they do, but we're not trained on how to use them. So the science teams also have to deliver some sequencing for us to bundle with what we're doing on that day. And yeah, that's kind of how the planning day goes. So for training, I'll hand it over to Keri.
Yeah, so I set up a whole new training pipeline for Curiosity, and now I started again on Perseverance just last week. So I'll be setting up my training pipeline over there. So we start out with classes that have homework. I'm sorry if you thought, graduating from school got you out of school. You do not. I'm sorry. So I start out with classes, and you learn all about how to drive the rover, how to use the robotic arm, and then you'll do homework and kind of practice labs where you get to pretend that you are sending stuff to the rover, but we're not actually letting you send it quite yet. We'll have someone grade your work and give you feedback. And then we do what's called PORGs, or Practical Operational Readiness Gambits. Of course, I go for a Star Wars acronym. They're the cute little Star Wars birds from The Last Jedi. And so they are simulations of that planning day that we do. So I'll have them come in at the normal time. You've got your timeline pressure, you interacting with the other roles, you're getting all that practice now that you're comfortable with the tools from doing the homework. And once you've done a couple of those and you're kind of comfortable, then we'll actually let you sit in the real seat and generate the commands for Mars, but you'll have a certified person checking over your shoulder, checking your work, making sure it's safe. And you'll do that for several months, and eventually everyone will agree, they know what they're doing. I don't have to check in on them that much. It's pretty good, and we'll give them their driver's license.
Brilliant. And in a way that answered one of the questions that came in, which is in terms of, and it was from Isadora, and they asked, what's a typical daily routine for you at NASA? And you've answered that in terms of driving, but is there, of course, there's going to be other parts of your job as well. So do you get to drive often, or is it like a once a month thing? What's a typical week or a typical day?
I think right now I'm averaging twice a week. It depends on how big our team is at the time and who's certified to do what, or if we're drilling as well. Because so I think I didn't answer this before. We have specific rover drivers that are assigned that day to drive. We have people assigned to use the robotic arm, and we have people assigned to manage sampling and drilling. So depending on what we're doing and what I've been assigned to, sometimes I just get released, and sometimes I'm driving a few times a week. The rest of my time, you're exactly right. There's strategic things that have to go on. We have to keep things updated. We have to update our ground tools. There's a lot of programming. There's also work in the test bed. I work in the Mars yard, like I said before. And so especially if we're doing something brand new or a new development, like right now, we are getting ready to upgrade the flight software for the first time, or second time, I guess, in the mission, but the first time in a long time. We have to test all that in the Mars yard before we ever send it up to Mars. So yeah, there's a whole lot of things for us to do in our normal days when we're not driving. They're a bit more relaxed, but yeah.
Yeah, and it looks a bit like an office job the other days. We have emails, we have meetings, we have PowerPoints,
And then you drive a rover on Mars.
Exactly.
We make memes about it. So.
Yeah, and that's another important one, make memes.
Just for the viewers who didn't catch your video earlier in the day on the Mars yard, could you just very briefly describe what that is? And it sort of is what it says on the tin, but could you give a brief description?
Yeah, the Mars yard is, so at Jet Propulsion Laboratory in Pasadena, we have a giant plot of land with dirt and some slopes and some sandy slopes. And at this point now, 2 large Mars robots living in it. So whenever we build a Mars rover, then we actually build a twin and keep it on Earth. And we send one to Mars, we keep the other one. And that way, if something bad happens, if there's an anomaly, or if we are trying to update everything, then we have an exact copy, almost exact, of what we sent on Earth to test that on. And I said almost exact because both of these rovers are nuclear powered, and we don't put that in the Mars yard and then make people walk about it. So keep it safe.
Brilliant.
Plugged into the wall.
And so in terms, there's one question that has come in from Key Stage 3 in Year 8, and they ask, why would it take so many years to get the samples back to Earth? So the ones that Perseverance is dropping off and leaving, and why would it take so long to get back? And another question that we've got here is, what are the main risks for Perseverance? So why would he break while they're on Mars?
Yeah, I'll take that one. So a lot of it just takes a long time to develop a spacecraft mission. It usually takes about a decade from somebody's first idea to then you have to design it. And as you're working through it, you're like, oh, maybe this design isn't going to work, and you have to go back and rework it. And so that's a lot of what's happening right now, is designing exactly what are all the specifications, how is this all going to fit together? Is it going to be a good design? Then it takes several years just to build those parts and put them all together. And once you've done all of that, then you have to test it and make sure that it's not going to fall apart. It's a lot easier to fix it here than once it gets to Mars. So they do a lot of testing. vibrating to make sure it'll survive the rocket launch and all sorts of things. And then finally, after that point, then you get to send it on the rocket. And then it takes like 7 to 9 months to get there. So it just takes a long time.
And you can only get there sometimes.
Yeah. So the way that the Mars and Earth orbits are, we can only send spacecraft to Mars about every 2 years. So that's why there's like spaces, if you notice, like they're about 2 years apart for these different Mars missions. And so we also have to wait for one of those windows to come along to be able to send this mission. So it just takes a long time to develop, build, test, send it.
Which makes sense.
Yeah.
And in terms of once you've actually sent a rover and a mission there, what are the risks, in terms of things going wrong? So obviously if you've tested so well, should things work?
Yeah, so a lot of these missions, we try and build them, to make sure that they're going to fit and complete their prime mission. So we have a set of objectives that like, by this date, we will do X, Y, and Z. And so, for Perseverance, we just ended our first, our total prime mission, which was the main goal was to make this sample depot, which we've now done. So after that point, it's kind of, the warranty's off. So for Curiosity, for example, I'll let Sophia talk a little bit more about it, but we've gotten holes in our wheels, so we've had to redesign how we drive. And as Sophia mentioned before, the drill kind of broke, so we had to redesign how to drill. And thing is, we're really good at solving problems. So even if something were to break, we're usually pretty good about like reworking. Sophia, if you want to add anything there.
Sure, yeah, we also, when we design these rovers, they're going to somewhere that nobody's ever been before. So we can have an educated guess about what the environment will be like. And usually we're pretty close, but there's still a lot of unknowns that we couldn't expect. For example, with Curiosity, we thought the wheels were going to be able to work on these rocks a little bit better. Curiosity is more of a mountaineering robot though, and those rocks ended up being pretty hard. So yeah, we've got big holes in our wheels we're having to deal with now. But some of the other risks that we'll see as well are like just using a rover for this many years. Curiosity has seen some wear and tear in some of the electrical systems because it's really, really cold and it's really, really dry. And those things are only going to last so long. Also, we get hit by cosmic rays. 200 days into the mission on Curiosity, we got hit with a cosmic ray and had to go on our backup computer since then. So you can't predict that. Nobody can. So that's just something that happens. That's space. Mars is hard.
And this is the thing when you're doing something that's never done before. If you knew exactly what those risks are, then you could mitigate for them. But of course, you can't know what all the risks are because you're doing innovation, and that's what it's all about.
Exactly.
Brilliant. We've got a few more questions. What are these? So in your photos, there were a few different color skies of Mars. What actually color is the sky of Mars, and do we know that?
Yeah, so being the Martian meteorologist, I'll put my hat on here. So the sky is kind of a pinky red color most of the time. My favorite fun fact is actually during the sunset, we get kind of the opposite effect of what you would get here on Earth. So if you think normally our sky is blue and the sunset's kind of the pretty pinkies and purple colors, well, it's the opposite on Mars. It's actually the sky is normally kind of reddish pinkish and the sunset is blue. And that has to do with the particle sizes in the Martian atmosphere. So, Earth is mostly nitrogen and oxygen, whereas Mars is mostly carbon dioxide. And so it also has a lot of dust. And so that affects how the light is traveling through the atmosphere. So it's kind of inverted from Earth, which is kind of fun.
That is really fun.
I'll just say we bring a little color palette with us as well that we calibrate our cameras with. So we do have a ground truth on what color things are when we take the pictures.
Brilliant, brilliant. And just one final question. I'm going to merge a few together. So in your presentation, it showed a really nice sense of community within the Perseverance group and within JPL generally. In terms of what are your favorite things about your jobs and what are the most difficult?
I'll go first. My favorite is definitely the teamwork. One of the reasons I didn't end up pursuing the PhD was in my master's program and before, I was just sitting in a cube coding by myself, and I hated it. I loved the work, but just being isolated from people, I really hated it. And one of the things that really drew me to operating spacecraft is it's still very technical, very scientific. We're pushing the boundaries of human knowledge. But I'm also working with a team, and everyone on that team is like super brilliant and awesome, and we all get along great, and it's just a really good sense of community. You know, Sophia and I were mentioning memes, you know, we make jokes, we hang out at happy hours, you know, it's a really good social environment. So that was the main thing that attracted me to working at JPL and has kept me going in operations. Hardest thing is just kind of getting over that imposter syndrome. It's that little voice in your head that says you're not good enough and you don't deserve to be here. And sometimes it tries to get the best of you. But the really good thing about being connected to this team is they also fight that same demon, and we're all pretty good about supporting and lifting each other up. Like Sophia and I have definitely had conversations that, like, you know, you go girl, and that sort of thing, right? So, you know, that voice can be a little hard sometimes, but that's what the teamwork is for, to help fight that demon.
Yeah, my answer is pretty similar. I love the work. I mean, like I said, I've always wanted to be an astronaut, and seeing something I worked on go to Mars and land there, and then also seeing something that, you know, the Mars rover went that way because I told it to go over there and I put the waypoint there. It's just the coolest thing in the world to me. And so between that and, again, the team is just incredible. They're the nicest people, and it's just a bunch of really excited people, excited to be doing what they're doing. And you can't ask for much more than that. And a similar challenge with me, so, you know, imposter syndrome is pretty common. I also have ADHD, and that got a little difficult to manage during COVID, but I figured it out now. And so that's something I've had to learn just my whole life, how to work through. And especially in a really technical, time-based environment, it can be challenging, but it's definitely possible to be successful. So you just have to figure out what works.
Brilliant. Thank you to both so much, especially for being so honest as well, because as we all grow up, we all have our certain demons and certain ways we feel about ourselves. And sometimes we think that it's just us that are feeling that way. And so for two NASA scientists to share that, I can imagine it's, you know, made a lot of people sigh with relief and be like, oh, it's not only me. But yeah, you two are definitely successful, and thank you so much for that talk. Now, we are going